Hello and welcome back. We're going to start our next video here with practice problems for our chapter 4. Once again, we're going to be moving along as if you've read the problem and attempted it. So here in problem 18 we have Greek life organizations and whether or not you binge drink or don't binge drink, and we have another 2x2 table here set up. So now we're going to do 2x2 table. Here's your A, B, C, and D, and these are just your totals here on the side. This would be your table total. You have row totals and then column totals, and that's what these values are representing. But our real data and info comes from our boxes A, B, C, and D. So number one has us to calculate the prevalence of binge drinking in each group. Keywords here, we're looking at prevalence of binge drinking in each of the groups. So there's two groups here that we're going to be looking at, and prevalence is the total number of people who normally have a disease or a condition divided by the total number. So here we're looking at the prevalence of binge drinking if you're in Greek life versus if you're in non-Greek life. Those are the two groups. So we're looking at 131 divided by 186, which equals 0.7043, or you can say 70.43%. And this is going to be Greek life organization. And then so no Greek life organization is going to be 102, the prevalence, over 252, which is equal to 0.4047, or you could say that's 40.47%, and that is how we calculate prevalence. Next part here, we're going to calculate odds ratio. Once again, remember, odds ratio is equal to A times D over B times C. Since we're not flipping this table around, it's exactly how we're looking at it. So we're going to take 131 times your value of D, which is 150, all over B, which is 55, times the value of C, which is 102. Once again, I like to work things out step by step. You can put this all in the calculator, but remember to use your parentheses most accurately. So when you work this out, you should get a value of 3.5027, which would mean that your individuals who are in a Greek life organization are 3.5 times more likely to binge drink than those who are not part of a Greek life organization, based on the information collected above. Number 19, we're starting into more probability here. And so this is one that's, I help you with part B, and in part A, we're trying to find, what's the probability of choosing a random patient who's covered by Medicaid insurance. So we look at Medicaid insurance, and we see that there's 276 people who have Medicaid. The total number of people, or total number, of people with insurance that we have here. So if you added this all up, you would get a value equal to 773. So 773 is our denominator here. So the probability of picking someone with Medicaid insurance is 0.35705, or you'd say 35.71%, 35.705% is the probability of choosing someone with Medicaid. Next part here, so we're doing a conditional probability. We're taking our probability from part A, and then we're given another part. So when we're doing conditional probability, we're trying to majority of the time solve for probability of B given A, and the way we solve for the probability of B given A is it's equal to the probability of A union B, or A and B, divided by the probability of A. But here it's kind of a little different because we're given the probability of B given A as 0.64, and we know the probability of A, which is Medicaid insurance, is 0.35705, which we found from the top part here. So, and what we're trying to find is the joint probability of receiving or even had Medicaid insurance. So we're trying to find the probability of A union B, or B, A and B. So we're just going to replace that with a value of x, because that's what we're looking for. Now when we do this, we have an algebra problem in which we need to solve for x. So we have to move we have to isolate our x value and then move our 0.3507 over to the other side. The way we do it is we multiply it out. So it's going to be 0.64 times 0.35705 equals x. x equals 0.240, which is the probability of our joint probability of receiving arrhythmia treatment and Medicaid coverage. So this is using a little bit of our algebra knowledge and our formulas for probability to solve. Moving on to number 20, where we're doing more of our probability. So I think everybody should understand how to do A, B, and C. D, I've kind of scratched out here. But if you want to try and go on yourself, it's a little bit more than I want everyone to go off. What we're saying here is, you're trying to solve for what is the probability of males given split drugs. So if you want to read this, put the probability of B given A, just like we did up top here in part B, the probability of B given A for the probability of males given split drugs. You can work that out. Remember, that's going to be, the probability of B given A is equal to the probability of A and B all over the probability of A. So go ahead, if you want to work that out, you can, but it's not necessary for what we're doing. I really want to focus on the A, B, and C here. So first part is we're trying to find what the probability of male and split drugs are. So if you take the probability of male and split drugs, this one's kind of a little more straightforward, because here we have males, here we have split drugs. We also have females and never split drugs. So we're looking at the probability of males and split drugs, so we're finding that value right there. So the probability of picking males and split drugs is there's 349 males who do split their drugs out of a total of 1,021 people, and this will give you 0.3418. So that one's a little easier to set up as long as your table is set up correctly. And then what is the probability of males? So the probability of males that we're looking at is, here's males in your row. So we're looking at total males, right? Because you could pick males who'd never split drugs, because we're just trying the probability of males. So the probability of selecting just a male is 673 divided by the total of 1021, which equals 0.6591. And the probability of males or split drugs, so the probability of male or split drugs is found by taking the probability of males plus the probability of split drugs minus the probability of males who do split drugs. So because the way to look at this is that you could pick a male, or you can pick someone who splits drugs. So you could pick a female who splits drugs, and there are males who split drugs, and versus just males who never split drugs. So what we're doing is we're trying to find the probability of male or people who split drugs, and taking out the people in between to get a more accurate probability. When you work this out, you're going to get, so I'm going to kind of put it right underneath there. So the probability of males, once again, is 0.6591, plus the probability of split drugs, 0.5572, minus the probability of male and split drugs, 0.3418. Work this out, you should get 0.8745, the probability of picking a male or someone who splits drugs. Remember, our probabilities have to be between 0 and 1. If you ever get a value over 1 with probability, that is not accurate. Okay, that's going to do it for this video. If you have any questions, always get in touch with me. If not, I'll see you in the next video. Have a great day.